Do you find math or science difficult or challenging, or you want to upgrade your metric? Krazifizix is your answer. The home of quality and inspired teaching of math and science. We offer the best service in teaching and simplifying concepts with fun and easy to remember dynamics. No one does it better. Many have had their dreams set in motion under our tutelage. We want to be part of your success story. We offer both actual and virtual tuition and homeschooling from grade 10 to 12. Are you working but need to upgrade your metric? Trust me, we got you covered, holding your hands till you make it for your metric upgrade wherever you are in South Africa. Our cloud and remote resources are adequately prepared to take you through every concept in detail. Simplified explanations, simulations to make you enjoy science and have fun with it. Textbook, workbooks, plug and play on the go class would also assist you as part of our resources. Why don't you just subscribe to our YouTube channel? Don't forget to hit the like button. Krazifizix or Crazy Edu TV. Register now for 2021. Send us an email at info@krazifizix.org.za. You'd never go wrong with us.
Hi, Krazifizix here again. In this particular video, this is the third video should you be getting this. Part 1 of algebra was broken down into A and B. All right, and this is part 2 looking at Euclidean geometry of grade 11, which also applies when you get to grade 12. We've done quite a bit of work here. All right, and we are going to look at this question here very, very quickly. In the diagram below, PQRT is a cyclic quadrilateral. You must understand what cyclic quadrilaterals are. All right, so the first thing is I'm going to quickly go identify my cyclic quadrilateral. They said PQRT. Now, while I'm underlining, while I am just highlighting that, you must understand that the properties of a cyclic quad. Okay, so we know that it's a cyclic quadrilateral. Beautiful. Opposite angles as supplementary. Exterior angle is equal to opposite interior angle. Okay, so we must know all of those games. The tangent at P meets RT. Tangent at P. Oh, where's my tangent? Let's use a blue line to draw the tangent. Since I've mentioned tangent, you know what I'm thinking about already. You should know. I'm thinking about tan chord. Okay, so when the examiner says that, I'm quickly thinking about tan chord. I'm thinking about tan rad. And I'm thinking about tangents drawn from, I'm just going to say two tangents. Tangents drawn from the same point. But in this particular question, I see there's only one tangent. Please take note, not a tangent. Why is it not a tangent? Because it goes into the circle. Tangents don't go into the circle. Automatically, I have cancelled out that. QP is equal to QT. All right, that's given also in the question. You see that those signs there. And PTS is 70. We see PTS outside. By the way, they did say RT is parallel. When I see parallel angles, I'm thinking about my front angles. Let's quickly highlight those parallel lines. I'm going to use a thicker black line. Those lines are parallel. Beautiful. Give a reason why P2 is 70. Oh, this examiner is so nice. They've already given me P2 as 70. But what could the reason be? Let me get a highlighter. What could the reason? All right, P2. Okay, wait, hold on. You've got to look at, this is how I do it. You've got to look at that angle and see where it comes from. The first thing I'm seeing is that, look, P2 comes from TQ, trace back. But that will not help us. The only 70 I see here is this. And that is not even a tangent. But wait, let's go back to P2. P2 comes from this line and that line. Wait, this line here has to do with something parallel. We're told that this is parallel to that. So this line has a connection with a parallel line because it's there. Where's my other parallel line? front angles. Ah, I see my Z or my N. Okay, let me just allow this highlighting to go. Oh, boom, done. P2, you must know all your front angles now. So P2 is equal to 70 degrees. Why? Alternate angles. RT is parallel to PQ. Always state the parallel lines, and we're done with that. Calculate with reasons the size of Q1. Calculate with reasons the size of Q1. Let's go check again. I'll quickly highlight. That's Q1. Q1 starts from where? Oh, wait. Q1 is between, watch the properties of those lines. All right, it's between a parallel line and this line. Front angles, no, that will not work. But hold on. This angle is between this. Oh, if these two are equal, I get it. It means this angle will also be 70. Why? Angles that are opposite equal sides. Angles that are opposite equal sides. And I can get my Q1, sum of angles in a triangle. You've got to state all the reasons that you get. All right, so that is A, my B. The first thing is I am saying T2 equals to 70. Angles opposite equal what? Sides. Or remember that we were given, let me do this. We were given that QT is equal to QP given. Therefore, T2 is 70. And please, to make Euclidean easy, any angle you get, write it there. So Q1 will be equal to, we add all the three together, 140, that's 70 plus 70, subtract from 180, Q is equal to 40 degrees. Sum of angles in a triangle. And you're done, 3 marks. You are done. Now we're looking for P1. Okay, by the way, we said write the angles in. It makes it easy, 40 degrees. We're looking for P1. Where is P1? Oh, let's go trace P1 again. Where is P1? P1 is between 2 lines. Wait, what do I see here? P1 is in between a tangent and a chord. Oh, done. Let's get a highlighter. So find the properties of the lines. It works all the time. P1 is between the tangent and a chord. I told you 10 chord. All right, what chord are we using? PT. That's the name of the chord. Where does PT subtend an angle? PT subtend an angle at Q1. Oh, so P1 is 40 degrees, 10 chord theorem. And boom, we are done. We're looking for P1. No, I had numbered wrongly. This is A, and this is B. So can we say P1 equals to 40 degrees? What's our reason? 10 chord theorem. And we are done. Easy. Next question. A, B, and C are points on the circle with circle O. Lovely. Center O. S and T are points on AC. Let's go find all of those letters. S and T. S and T. Okay. Such that OS is perpendicular. I see something. Theorem 1. A line drawn from center perpendicular to the chord will do what? Will bisect. It means this and this are equal. Okay. OT is perpendicular to AB. Oh, the same reason. A line drawn from center that is perpendicular will bisect. Those lines are equal. AB is 40. Okay. AB. Oh, but these lines are equal, so that will be 20 and that will be 20. AC is 48. The whole thing here is 48. But since these lines are equal, that will be 24 and that will be 24. Oh, great. That is my analysis. Calculate AT. I think we're done. AT is 20. 2.2.1. Let's write the answer. 2.2.1. AT is 20. Why? Line drawn from center perpendicular to the chord. That's your reason. You get your first one there. Second one, if OS is equal to 7 over 15 OT, calculate the radius OA of the circle. Let's go, there's so many things going on here. If OS, where's my highlighter? OS is equal to 7 over 15 OT. Oops. That's between two triangles. Find what? The radius OA. Let me draw OA out. Now, one thing I have seen here is that OA is a common side to both triangles. All right, this is one triangle here. Oh, so OA is a common side to both triangles. Let's use our Pythagoras theorem. That's the rat. Okay. Right angle triangle, rat. Okay, let's look at the black triangle here. OA, which is the radius, is a common side, and it's the hypotenuse. Can I say OA squared, follow through, equals to OT squared plus AT squared? OA squared equals to AT squared. Let's do something to make it easier to see these letters. I'm just going to do something here quickly. Okay. All right. I did something terrible now. Just want to, so that. Okay, beautiful. Let's do this to make it easier to see my letters. Lovely. Okay. So we come here and say OA squared equals to what? OT squared plus AT squared. Remember, theorem of Pythagoras. So we can just write Pythagoras theorem. It's important to write that. Okay. By the way, we know our AT. We got AT already. Remember, AT is 20. We do not know. All right, let's see. So OA squared. Do we know OT? No. What is my AT? We got AT earlier on as, what did we get? Oh, it's right here. AT is 20. 20 squared. That will leave me with OA squared equals to OT squared plus 400. I'm going nowhere. I'm going nowhere. Let's go check the second triangle. OA is also triangle, so this is in triangle OAT, and this is in triangle OAS. So OA squared as well is equal to OS squared plus AS squared. Same reason, Pythagoras, all right? But can we say our AS is 24? We said that earlier on, line drawn from center. Make sure you keep writing your reasons. All right, perpendicular to the chord will bisect. It means my OA squared is, what is my OS? Oh, we are given OS as 7 over 15. OT, or squared, plus, now it's algebra, guys. It is algebra. It's all a question of your algebra. It's all a question of algebra. I have two equations with two unknowns. But I see that both of them are equal to OA squared. OA squared equals to that, OA. Oh. So since OA squared, let's just substitute. Instead of writing OA squared, I'm going to write this whole expression. 7 over 15 OT or squared plus 24 squared. That's my OA squared equals to OT squared. I hope it makes sense. Let me quickly re-explain that. Somebody might just look lost. This is my equation. But what is OA squared? OA squared is that. So instead of writing this OA squared, I am writing that. If you notice, the only variable I have left is OT squared. Let's simplify. We expand the whole thing. 7 squared times 7 squared will be 49. All right? We expand that. 49 over 225 OT squared. Okay? I hope that makes sense. I hope that makes sense to you. We're just now doing algebra. Euclidean is actually done. What is my 24 squared? 576. Beautiful. Equals to OT squared plus 400. Okay, can I rearrange? We bring that there and take that there. So 49 over 225 OT squared minus OT squared equals to 400 minus 576. Interesting. Now, if you use your calculator there, 49 minus 225, you do it your way, minus 176. Okay. Remember, this is minus 1, so it's minus 176 over 225 OT squared equals to minus 176. 400 minus 576. Okay, we're just doing maths now. I hope you understand how I got my minus. It's 49 over 225. Let me do this for everyone. 49 over 225. Because they are like terms, we subtract. That's where I got my negative 176 from. Okay. Let's get OT squared. There we go. What do you do? It depends on you now. All right? It really depends on you. You can divide both sides. Divided by negative 176 over 225. So OT squared is negative. You can use your calculator. I'm old school a little bit. And that will divide. So OT squared equals to 225. What is that? The square root of 225. OT is actually 15. But remember, we are not looking for OT. We are looking for OA. So we go back to one of our equations. We're looking for OA. All right, OA squared equals to OT squared plus 400. Beautiful. OT squared plus 400. And what do we have? 15 squared plus 400. That will give us 225 plus 400. And that will be 625. But this is OA squared. What is OA? The square root of 625. And that will be 25. 25 units. And we're done. So it's the beginning was Euclidean and the rest was algebra. Algebra is just everywhere. All right, I have one more question to do quickly, and then I'll have a few other questions which will come in the second part of my Euclidean. All right, in the diagram, O is the center of the circle. A, B, C are points on the circumference of the circle. Chord AC and BC, radii A, O, B, O, C, O are drawn. Okay, these are already drawn. Radii, that's a radius, that's a radius, that's a radius. You know what I like to do is to write radius. Radius. It just makes me see, and that line is equal to that line, equal to that line. Determine the size of O1 in terms of x. Where's O1? Oh, it's outside. Okay. This is giving us x. Automatically, that would be x. Why? Angles opposite, equal side. So, I'll say that they've already given us the radius. So, I'll just go ahead and say C1 is equal to x. Angles opposite, equal what? Sides. And then I know my O1 is an exterior angle. O1 actually is A plus C1, which is x plus x, and that is 2x. What's the reason? Exterior angle of a triangle is equal to sum of opposite interior. So O1, the examiner said in terms of x. So we're done. Hence, prove the theorem that states that the angle subtended, okay, so that is 2x, by an arc or a chord at the center is twice the angle subtended by the same arc. Oh, so angle at the center is equal to 2 times angle at the circumference. All right. Now, you've done the left-hand side. We are going to do the right-hand side. This is going to be y as well. Same reason. And this is going to be 2y. You've got to state all the reasons, okay? So I'm going to come here and say C2 is equal to y. Angles, opposite, equal sides. Which makes O2 to be 2y. Exterior angle is equal to sum of, you must say sum of opposite what? Interior angles. Beautiful. Now let's look for angle at the center. O1 plus O2. But what is O1? From the previous question, okay, we can just simply say O1 is equal to 2x, already proven. Now, what do we know? O1, you need to write this part, very important. 2x plus 2y. 2 is common. X plus y. Oh, now let's check something. My O1 and O2 is actually AOB, that angle. Okay, I'm just going to write on the question paper now for space. O1 plus O2, therefore AOB, which is my O1 plus O2, is equal to 2. What is x plus y? X plus y right here is this angle there. Oh, which is angle ACB. Beautiful. And we're done. Angle at the center. This is my center. Oh, that's what we want to prove. This is the angle at the center. Is 2 times angle at the circumference. Okay, circumference. And that's a standard proof that everyone needs to know. I have a few more other questions which I will deal with just for us to understand how to work around. I have 3 questions, and I will deal with that in the part 2 of our Euclidean. So, again, this is going to be part A. We would then walk around, look around, and keep watch for part 2 of our Euclidean, which is just solving a few extra questions. This is me signing out, saying goodbye, everybody, and catch you later.